Morning, good evening, or whatever time you're watching this educational video. This is our very first lesson in General Physics 2, which is all about electrostatics. Before we will venture to what is electrostatics, we have to define first, or let us know what is an electromagnetism. It is a branch of physics that studies electricity or electric and magnetic phenomena. And from the name itself, it's very clear that it talks about electricity or electrical charges and magnetism. It has two branches. We have electrostatics, that's the concern of this video, and we have electrodynamics. The difference between the two branches of electromagnetism: electrostatics, the study of electric charges at rest, no motion. And on the other hand, we have electrodynamics. It's the opposite of electrostatics. Dynamics, it talks about movement or motion. So, electric charges in motion. So, what are the topics involved in electrostatics? We should know about electric fields, electric potential, charging, and Coulomb's law. In electrodynamics, we have electrical current, the flow of current, circuits. Ohm's law is part of that. We have magnetic fields also in moving charges, and then the Maxwell equation. As you can see in the picture, electrostatics, because that's the concern of this video, one branch of electromagnetism, it focuses on electric charges at rest. And I highlighted there electric charges. We can incorporate electric charges with the building blocks of matter, the atom itself. So it will bring us to the building block of matter when we will be discussing about electric charges. And it makes matter electrical in nature. If you can see on the background, I have one atom there. One, two, three, four, five, six, seven. It has seven electrons. So the seventh element in the periodic table, this is the structure of the atom on, you know, uh, the occupant of the seventh spot of the periodic table, the elements having atomic number seven. It has seven electrons and, of course, seven protons. That's a neutral atom. So, again, charges, when we talk about charges, it has something to do with the two subparticles of atom that contains the charge. Okay. Atom consists of relatively massive nucleus, the protons and neutrons, and diffused by a cloud of moving or mobile electrons or orbiting electrons around the nucleus. Okay, and the subparticle mass, please take note on this. So it is being ranked from heaviest to lightest, and they are light, I guess, because one atom is very minute, and the masses there are in lesser numbers. Okay, it's the neutron is the heaviest among the three. Okay, it has a mass in kilograms 1.675 times 10 raised to negative 27. Next is proton, 1.673 times 10 raised to negative 27. Just a little uh, difference. And we have the lightest among the three subparticles, the electron, 9.11 times 10 raised to negative 31. These two subparticles, we have protons and electrons. They carry the charges, or we call it the electric charge. And that's why we will go back to the nature of the atom. as we talk about electrostatics because it focuses on electric charges at rest and electric charge is present in the atom, within the atom, especially with these subparticles, proton and electron. In physics, we will gonna use Q as the symbol for our electric charge. When we say electric charge, please take note, an intrinsic property of protons and electrons. The protons contains or carries, protons carry and contain the positive charge, while electrons carries or electron carry the negative charge. Okay, and it is also being compared to the property of mass. Matter in matter, one basic property of matter is the mass itself. So in subparticles or in the atomic level, when you talk about electrostatics, electric charge is the uh, not quantity, but it's the property present in the subparticle of the atom. Okay, so it is being compared to mass. All matter has, or all matter have masses, while particles of the atom also contain electric charge. And it is also defined as the state of having more electrons or negative charge or protons. So we can say that it has a charge. It has an electric charge once there are many excess electrons or lesser electrons and stuff like that. Okay. Now let's proceed. Let's go back knowing atom again. It's most of the time atoms are neutral. Most of the time, neutral meaning they don't possess any charges. Okay, they are not electrically charged. They are neutral. And when we say neutral, equal number of protons and electrons. That's the basic of it. Neutral atoms, they have the same number of protons and electrons. And then atoms will have charge if there is an imbalance of electrons, meaning electrons now is not equal, or the number of electrons now is not equal to the number of protons. So there is an imbalance of electrons. We call it neutral when they have the same number of protons and electrons. And when there will be imbalance or there is unequal number of electrons and protons, charge will happen. Okay, or there is now charging, or a certain atom is now electrically charged. If atom has more negative, it has a lot of negative, it is said to be negatively charged. On the other hand, if an atom has more positives, it is called positively charged. Or in chemistry, we can specifically coined or specifically call this, uh, let's say, instance or entities when there will be many negatives, so we can or many positive, we call them ions at all. They're not neutral atoms, but they are charged atom or ions. If you could still recall, the the atom contains many positive. For example, you have four protons here, the positive one, and you will have three electrons. One, two, three. Literally speaking, it has many electrons than many protons, sorry, than electrons. So we can say it's a positively charged ion or atom, and in chemistry we call it cation. And another example here, by the way, this is a neutral atom. It has equal number of negative and positive. So that's neutral, no charge. The next one, it's a cation. So from the name itself, it has more positive than the negative. So it has charge already because an atom will be charged when there will be imbalance of electrons. There will never be an equal number of protons and electrons. So in this case, it's unequal. There's many positives than negatives. So therefore, it's a charged particle, specifically called cation. An ion is the opposite. It is when an atom will have an imbalance of electrons, not the same with protons at all, more negatives than the positives. So that's an ion or a negatively charged particle or atom. Okay. Um, an atom, once again, it's most of the time it is neutral without charge at first. But yeah, when there will be imbalance of electrons, this atom will turn into ion or a charged one. How to let, there is a question here, how to let a neutral atom be charged? How will you charge a neutral atom or a neutral material, a certain matter with a neutral atom? Because it says that atom most of the time it is neutral. So the atoms in a particular object, uh, at first they are neutral. So how to let a neutral atom or neutral atoms be charged? How to let a neutral atom be charged? Blame it to the nature of the particle carrying the negative side, negative charge. So the main character of our lesson throughout the semester will revolve on the nature or the scope of the charge that carries the negative charge or the particle that carries the negative charge, which is the electron or the negative charge. Okay, this is the reason why charging will happen or charging will exist because of the characteristic of electrons. So let's try to know what is an electron. Although this is a very basic for you, but yeah, a review might help you to be refreshed. Electron, because of the electron, charging happens when electrons are imbalanced, like what I have said. The neutral atom, it has the same number of electrons and protons, but when there will be imbalance of electrons, one atom will have more negative. So that's a negatively charged ion. So there is now charge. And then when there will be less negative, therefore it has many protons in it. So that ion is a positively charged one. And that will only happen when electrons are imbalanced. And how will it become imbalanced? It is when electron transfer from one matter to another. Always bear in mind that um, electrons are the subparticles that will be transferred from one atom to another. Will be like free from an atom and then to be accepted by another nearby atom. Okay, it's the electron, not the proton or the neutron. Protons together with neutrons, they made up the mass of the atom and they always stay in the nucleus of the atom while the electrons are clouding and moving around it. And the last electron uh, on the last shell, or we call it the valence shell, uh, these electrons are very far from the nucleus. So the attraction between electron negative and the positive proton is getting weaker. So this electron can be freed and then thrown away and accepted by another atom. Electrons are loosely bound. We have a term here, affinity. It's just the capacity of the object or the atom to hold its electron. High affinity means the atom can hold its electron. Low affinity meaning the atom can have a tendency of freeing or losing its electron easily. Okay, and we have our North Star to know what material will lose electrons easily or what material will hold firmly its electrons. So we have the triboelectric series for that. Okay. And valence electrons, like what I have said, they are far from the nucleus. They will be weaker, so they can be thrown out from the atom and be received by a nearby atom. Electrons move due to potential difference. Potential difference is a term for voltage. We will be knowing voltage in our uh, um, l- other lessons in this semester. Okay, when you encounter the word potential difference, it's the voltage. It's the force that will push something. And of course, it will push the ones that will always move in the atom. That's the negative particle or the electron. So electron will be pushed by this so-called potential difference. Just okay. And then in terms of electrons transit or movement, it depends on the situation. We have one if we talk about voltage difference. The second one, we will have the electron concentration, although they are just mainly connected. And the transit or the movement of electrons, when we focus on voltage difference, it's from low voltage potential or voltage difference to a high voltage difference. And then electron concentration, when we focus on the number of electrons, the electrons will move from high concentration of electrons to low concentration of electrons. Again, these two are just the same thing. Because, for example, or I will just make a separate slide for this. For example, class that low voltage means there are a lot of electrons in that. Okay, and then high voltage, less electron. So if you will gonna connect it with electron concentration, it will always move from high to low. And when there will be high number of electrons, the voltage will become lower. And then you will have a low number of electrons, the voltage there will become higher. So if you notice, when you will focus on voltage difference, the movement of electrons will be from low to high. While if you will just focus on electron concentration, it is from high to low. Please be mindful about the difference. Okay? How to move electrons or how to charge a matter? This is now a good question to start. When is the time that electron will be freed or will move from one atom to another or from one material to another? And remember, when there will be movement of electrons, there will be an imbalance of electrons. So again and again, when there will be imbalance of electrons, the atoms are no longer neutral. They carry a charge. So they are now a charged atom or ions. How to move electrons or how to charge a matter? I have here a picture. If you notice, you have a sodium atom here and then a chlorine atom. When you will combine them, you will form it will form an sodium chloride or like table salt. Okay. If you notice, the sodium loses its electron and then accepted by chlorine atom. At first, they have equal number of protons and electrons. They are neutral. Okay, at first they are neutral. But then again, after some mechanism, the sodium lose its electron, and of course, if the sodium lost its electron, so it there is now an imbalance number of electrons. And when electron is being freed, so sodium now will have more positive than the negative. Okay, because at first it has 1, 2, 8, 10, 11, and then 11 electrons at first, and then chlorine has this number of electrons. Okay, and then sodium loses one electron, so from 11 it becomes 10, and then in this case, the positive or the protons of a neutral sodium will have 11 protons, and the electron is 11. That's for neutral. Okay, and then it loses an electron, so the electron of the sodium becomes 10 because it gives out one of its electrons to chlorine. And if you notice, it has more positive now. So the proton will become the positively charged. And then the chlorine receives another additional excess electron. So it added its electron. Okay, number of electrons. So this chlorine will have more electrons than the proton. So the chlorine will be negatively charged. Okay, it loses electron, and the atom or the particle will become positively charged when it loses its electron, because uh, atoms are neutral in general. They have the same number of electrons and protons. Once there will be a freeing or losing of electrons, so there will be imbalance now. Uh, Electrons is getting decreased, and then the proton, since it's not moving, it's there. So it has more positive. So that ion will become positively charged. And then the one that gains electron or added, or there is an additional electron because the atom receives it, okay? So it gains more electrons. So they become negative because there's an additional electron. I hope it makes sense. Okay, how to move electrons? So how will it happen? Okay, the bottom line of it, I just wanna remind everyone that it's the electron that moves, not the protons. But some other articles or pictures, we will just use proton, the positive one that will move, just to appreciate that there will be movement of charges. But in reality, it's the electron that will jump to another material. It's not the proton. Okay. So we have charging methods. We will be knowing them one by one. But in this video, we will be focusing on one charging method. We can have contact electrification. From the word itself, contact, there's like touching mechanism, or they have direct contact with the other material. We can categorize triboelectric charging and contact charging as contact electrification. These are two of the common methods to charge a material. Triboelectric charging is just another term, or like another way to say charging by friction or charging by rubbing. Okay, when you will be encountering the word triboelectric charging, don't be afraid with the word. That's just friction. You rub things, and then after that, from neutral, it becomes charged materials. The contact charging, that's charging by conduction. And then we also have charging method that doesn't involve contact. That's the non-contact electrification. One example or one method is induction. Okay. So again, we will be focusing on triboelectric charging or friction, charging by friction in this video. When we say contact electrification. Yeah, there's a direct contact, and one example, which is our focus for today, triboelectric charging or friction charging or rubbing where friction. It started with two neutral materials. Please take note. Neutral material, same number of protons and electrons, no charge. And there is this mechanism called rubbing or rub together. When there will be rubbing, that's triboelectric charging. That's not conduction. Okay. When rubbing is involved, it's definitely triboelectric charging. Example, when you rub plastic ruler with a wool cloth, you rub it at first. At first, they are neutral materials. The wool cloth has the same number of protons and electrons. The plastic ruler will also have the same number of protons and electrons. But when you rub them, there's something happen. You charge both objects. Okay, you're beginning to charge both objects. Electrons move from a wool to plastic ruler. That's according to electron concentration. When you could still recall, if you could still recall, sorry, if you could still recall, when we talk about electron concentration, the movement of electrons is from high concentration of electrons to low concentration of electrons. So between these two objects here, electrons move from the wool. So the wool contains many electrons to the plastic ruler, which contains lesser number of electrons. So the electrons move from higher to lower. Okay, and we will try to know which one will lose the electrons. Is it the plastic ruler or the wool, or which one will hold its electron or will just accept the electrons? Okay, and yeah, this is the question. What material will give its electron and what material will receive the electron while you are doing the triboelectric charging or when you rub them? Which one will lose the electron? Which one will receive the electron? So it has something to do with electron affinity. It's the ability of a matter or an object or an atom to hold its electron. There are materials that, uh, tend to hold its electron than giving it. And there are also materials that are having the tendency to lose easily electrons. That's electron affinity, how they will hold electrons or how easy they will give their electrons. The triboelectric series is our North Star to know which one will give its electron or which one will receive the electrons. So I have a simple triboelectric series. It's incomplete, but you can surf on the internet about more examples of materials, and they rank it, which one will lose electrons and which one will accept electrons. So I have here the rabbit fur, hair, glass, wool, and silk, paper, up to Teflon. When you go down from the series, these materials will tend to gain electrons. So their affinity is lower because, no, sorry, their electron affinity is like higher because they tend to hold their electrons. They will not give it away. They will just gain electrons when there are free electrons nearby. They will not lose electrons. So that's why additional electron will be received by these materials and they will become negative. Okay. And on the other hand, when you go up from the series, from wool to rabbit fur, the electron affinity of these materials from wool to rabbit fur, um, the affinity is lower because they tend to lose easily their electrons. Okay. When you will compare wool and rabbit fur, the wool will easily donate or transfer its electron than the rabbit fur. Okay. So as you go up to the series, um, they will lose electrons. So their electrons will be decreased. And then in that case, there is an imbalance of electron. the proton is having greater in number than the electron. So that's why they becoming positive because they free electrons. In this case, I highlighted wool and polystyrene. It's like plastic. So I just assume that a plastic ruler belongs to that kind of material. So the ruler, or let's say let's begin with the wool. Since in the triboelectric series, the wool tends to lose electron. So the wool lose electron or the negative charge, and this negative charge will transfer from the wool to the um, plastic ruler. And now the ruler, um, sorry, then the wool will become positively charged. Why? Because from neutral, always remember it begins with two neutral materials. So from neutral, the same number of protons and electron, and then due to rubbing, the wool tends to lose electrons. So electron is now decreased, and then the proton remain the same. So if you will compare, at first they are having the same number of protons and electrons, but then after rubbing, it lose electrons. Then the wool will become positively charged. Meanwhile, the ruler, which is made up of polystyrene, as I assume, it's a kind of plastic, it gains electrons. So there's an additional electron, so the ruler becomes the negatively charged. If you notice from neutral materials, same number of protons and electrons, the ruler and the wool, they are neutral at first. When you rub them, that's your method to charge them. And then after rubbing, one will have the positively charged one, and then the other will have the negative charge. Okay. And from neutral, and then after rubbing, they have now charges, different charges. One is negative, one is positive. That's the beauty of triboelectric series. That's the beauty of triboelectric charging, or charging by friction or by rubbing. From two neutral materials, after rubbing, one will have positively charged, especially if it's the one to lose electron, and then the other one the other one which receives the electrons, they are now the negatively charged one. So it ended with different charges from neutral, and then after rubbing, one is negative charge and then the other one is positively charged. And we have electrostatic law, just like magnets, like charges repel. That's very basic, and unlike charges attract. In this case, the wool becomes positively charged and then the ruler becomes negatively charged when you will try to put them in contact, because we're talking about contact electrification. These two will attract. Okay. Going back, two neutral materials are rubbed together, and then after rubbing, once rubbed, one must become positive and the other must become negative. Different charges will be the result of this triboelectric um, charging. Okay, this famous experiment, rubbing a balloon on your hair. Okay, you rub a balloon on your hair, and then what will happen after that? Okay, when you will compare using the triboelectric series, hair tends to lose electron. So the electron will like jump here to the balloon because you rub it. There's a contact mechanism, and then you're rubbing it. So the hair will lose electrons. It will be received by the balloon because the balloon will gain electron. So the balloon now has many electrons, so the balloon will be the negatively charged material, while your hair in this portion will have lesser electron and many positive, so your hair will become the positive one. Okay. Rubber balloon has high affinity because it tends to hold its electron, not give its electron, but yeah, receive the free or excess electron from the hair. Okay, so when something gains electron, after that it becomes negative. There is an additional electrons in it, and the hair has low affinity because it tends to free its electron and become positive because there is like a loss of electrons. So electrons decrease and then the positive becomes the same in number. So that material will become positively charged. Unlike charges attract, and note it started from a neutral thing. Before rubbing, balloon is neutral, hair is neutral. After rubbing, the hair becomes positively charged and then the rubber become negatively charged. They're unlike charges, so they can attract. So that's why the hair is attracted to the balloon once you will place the balloon near to your hair, or you will contact the balloon directly to your hair. And what about this time? You remove the balloon, and then the strands of your hair is just like flying away, still flying away. Why? Why is that so? This area of your hair lose electrons, right? And then the strands there are having the same charges, positive. So according to electrostatic law, like charges repel. So that's why at couple of seconds or yeah, seconds, your hair remains like flying away, not touching each other because the positive charge there, um, the positive charge there, they're repelling. There's a repulsive force in them because they're like charges. Like charges repel according to electrostatic law. Okay, and then if you want that to like um not flying away, all you have to do is just touch your hair because your hand will have like electrons there, and once you will touch your hair, the electrons from your hand will transfer to your hair, and it will now balance. It will be going back to neutral situation. Okay, so the North Star, that's the end. We're not yet the end, but it's like closer to the end of this video. The North Star for triboelectric charging. We will be discussing conduction and induction in my next video. Both materials are neutral before rubbing. Please take note. Same number of electrons and protons. Both materials will have neutral. Um, neutral one. Will have a neutral situation, meaning they don't carry charges before rubbing. But once you will perform triboelectric charging, during rubbing, electrons move from one material into another. Um, it depends upon the capacity of each material to hold or free electrons. And we have the triboelectric series to check which one will donate electrons or which one will receive electrons. Okay, we call it electron affinity. Now, the materials that freeze electrons, meaning they lose electrons, so they become positively charged. The materials that holds and accept free electrons, there is additional number of electrons, so they will become more negative or negatively charged. And these methods, after rubbing, um, lead to attraction because it will uh, uh, it will result to two different charges. One will become negative and then the other object will become positive. Unlike charges will attract, there will be attraction. And also, there will also be repulsion. When you will expose, for example, when you will expose a positive object to another object that is having a positive charge as well. So, uh, like charges repel. So, this triboelectric charging from neutral after rubbing, it resulted to different charges. One material will possess positive charge, meaning they lose electron. And then the other one receives the electron and it's now a negatively charged material. And by that, there is an attraction between the two objects, or that positive object, you touch it to another positive object. So, like charges will repel. That's it for this video. I hope it uh, helped you at some point to review electrostatics, specifically about triboelectric charging. Okay, if you like this video, you can share. And yeah, that turning effects there, you can click that one, or I mean, you can subscribe if you like. Thank you so much for watching, and see you around in my next video. Bye for now.